Hi, this strange fossil is a representative of the second group of fossils that we need to uh, understand and study as zone fossils. It's a group called the graptolites, and it's perhaps a group that we're less familiar with, or less well known than the ammonoids, and particularly the ammonites, that we've just been looking at. Now, graptolites are a little bit enigmatic. They're very old. They've been extinct for a very long time, but they are really very useful zone fossils for an earlier period of geological time than the ammonoids cover. We're working on pages 12 and 13 of your Theme 9 booklet. And let's start by having a look at what these animals are. Like I said, they're a little bit odd. They're quite small, they're quite fragile. These things floated around in the sea in huge numbers. They are actually a colonial organism, which means there are lots of individual animals that live together in the same structure. We have different branches on this animal. It is an animal, not a plant. They're called the stipes, and in each of these branches there are a whole series of pockets that we call theca, and in each of those theca there lived an animal. The best analogy I've heard of these is a graptolite is like a block of flats, with each stipe being a separate block, and each theca being a balcony in that block of flats that an animal can live on. Now, these organisms show some of the key features of a zone fossil. They are very abundant. They're geographically very widespread. They evolved rapidly and became extinct rapidly with a series of very distinctive changes. The animals themselves are actually very rarely preserved. We only have a very basic idea, perhaps, of what the animal was like, and it really isn't similar to anything today. This shows the time zones at which some of these different types of graptolites lived. Now, you don't need to know any of these species names, but you can see that they lived for a relatively short period of time. The bar represents where they existed. The cross part at the top, the T, represents the point of their extinction. Interestingly, like Nautilus with the ammonoids, one of the earliest forms, called Dictynemia, was also one of the last to become extinct. You have some information there about this species, Climacograptus. Can you fill in your version of this table, question 8a, with its evolution and extinction? Where would this Climacograptus appear on this graph? Okay, if we have a look at what you've drawn on your graph, then Climacograptus has a time range that looks a little like that. We can see then that these fossils along the bottom of the graph are actually arranged in time order, with the earliest ones on the left, the youngest ones on the right. What I'd like you to do now is to see, can you identify some of the evolutionary patterns? What's changed between Dictynemia all the way to Monograptus? Use the terms stipe and theche. How can you identify those patterns. Okay, let's see what we've come up with. This is another perhaps simplified diagram of the same evolutionary change that we see in the graptolites. We can identify several different evolutionary trends from these fossils. Now, these are general rules and there are some exceptions to this, but we can see some overall patterns. The first of these is that the graptolites go from hanging down, what we call pendant, to sticking up, what we call scandent. The second change, and perhaps the most obvious one, is that the number of stipes decreases over time. We go from lots of stipes to 4 to 2 and eventually just to the 1 stipe. We also see the thecae changing shape. They start out as very simple pockets and they become gradually more complex over time, so that Monograptus actually has some quite curved and hooped thecae. So those are our key evolutionary changes. Those changes allow us to use graptolites to zone the Ordovician and Silurian periods of geological time. What I want you to do is to have a go at question 8b. This will give you the opportunity to have a go at zoning these fossils, knowing those evolutionary changes. That allows us to be able to split up the Ordovician and Silurian periods into time zones. What I'd like you to do is have a go at doing some of this yourself. This is some real data. We've got various different graptolite species. You've got some indication as well about how widely spread they are. Think back to what we did in the previous lesson about how important that is. And I'd like you to divide up this time period and define the name of the time zone by the fossil that best represents it. Now, what you need to do for this is to be drawing horizontal lines across this diagram. Time is the vertical axis. Draw horizontal lines to divide this up. It's real data. It doesn't fit nicely into a pattern. You need to use your best judgment to divide this up. Okay, have a go at that, see what you can come up with. Press pause now and do question 8b. Okay, let me show you what I've done to zone this diagram, or to zone this period of time. The first zone for me finishes at that point. We've got a widespread fossil that defines that time quite nicely, Didymagraptus bifidus. My next zone falls in here. Again, well defined by Didymagraptus murchisoni. These two fossils, by the way, are quite common over in West Wales. My next zone is there. Now, this is the tricky one. It doesn't really finish on the extinction of any one particular species. But I've called that after Glyptograptus terratisculus because it represents that time zone. But notice it's not unique to that time zone. The time zone above, though, we can define by Nemograptus gracilis. That's my interpretation. You may, of course, have come up with something slightly different. Remember, it's real data. It doesn't always fit into a nice, simple, easy Year 8 worksheet type pattern. Okay. We can see from this that the graptolites have some clear evolutionary patterns. Combine that with rapid extinction, rapid evolution, along with fossils that occur in huge numbers, and we have a good zone fossil for the Ordovician and Silurian periods. Next time, we need to move on and we need to start thinking about other ways that we can relatively date rocks. I'll see you then.